Hey everyone, I'm Uttam Singh, DevRel at Flare, and in this video we are going to talk about Flare Time Series Oracle, also known as FTSO. So what is FTSO, what is Oracle, why it is better than other oracles, and also how to use Flare Time Series Oracle to retrieve price data. So let's get started with our video. So blockchain technology is amazing and it's growing rapidly, creating an impact in every sector from banking, healthcare to finance. But like with every good thing, it has its shortcomings, and also blockchain has one. Now, what is that? One such problem with blockchain is that they are usually closed systems, which means that they are good at securely using their own data, but they are not able to securely access and use off-chain data from other blockchain or outside the world, right? This is called the oracle problem. The solution to this problem is to use an oracle, which is an entity or service designed to make off-chain data available and usable on the blockchains. They serve as a point of connection between the outside world and the blockchains. But how do we know that the oracle is correct and can be trusted? The answer is that we don't know this in general, yes. But we can implement mechanisms to incentivize good behavior and make it very hard to cheat. Apart from risk of getting wrong data, we also want the oracle to be available and not dependent on the single entity or any single source or the infrastructure, right? So let's actually talk about Flare time series oracle. The Flare and the Songbird network use a system called the Flare time series oracle, the FTSO, to provide variable data feeds on chain. At the moment, it is focused on providing cryptocurrency prices, but the other data series can also be added in the future. The FTSO is a decentralized oracle system that is supported by a combination of multiple around 90 plus data providers who provide prices in a decentralized way. The price information is not dependent on a single entity, and that is a great thing. And the incentivized structure encourages the provision of accurate data, making it very hard to maliciously provide an incorrect price. Now, are you wondering what are the advantages of FTSO over other oracles and why you should really care about FTSO? Then let me answer your question. First of all, FTSO is highly decentralized. Almost 100 data providers makes the FTSO decentralized. They are independent entities to Flare and not owned or managed by Flare in any of the way. Secondly, it is rapidly updating. The FTSO data is currently updated every 3 minutes. The future version of the FTSO may shorten this interval. Also, it's extendable, which means that more prices and other time series data sets can be added. Also, it is accurate. The FTSO incentivizes the accurate provisions of the data to the network. Incentivized participation. The Flare token holders receive a share of the FTSO rewards earned by the specific data providers they have delegated the tokens to, right? Now let's learn how actually FTSO works. The independent entities known as data providers are required to harvest and collect individual price pair data for a set of cryptocurrencies from exchanges. They then send this data to Flare by signing a transaction containing all the information. The FTSO system on Flare computes a price estimate for each cryptocurrency and make it available for any user or application to request the data they require. This data can be used for any number of use cases such as asset prices in decentralized lending protocol, or there are infinite number of use cases. In this process, each data provider's submission is weighted by its stake, and any stake delegated to it by any Flare token holder. This creates a representative reward system that reflects the community trust in a particular provider. It enables an incentivization system where all stakeholders can actually receive a share of rewards. Rewards are based upon the data provider's submission and how close it is to the computed estimate. The whole system is developed with upgradability in mind, so the new FTSOs can be deployed with a governance vote. Now let's talk about how to get the price information from the FTSO system. The FTSO system is a collection of smart contracts that are deployed on the Flare network. On the screen you can also see there are bunch of smart contracts. So this FTSO system is basically a collection of those smart contracts. So we will use a Flare provided library called the periphery package, which you can also see on the screen, and you will find the link to it in the description, that contains the necessary interfaces and mocks to interact with the FTSO system and can be used in the same way as we use our libraries like OpenZeppelin library. The library we use has interfaces adapted to Solidity version 0.8, and each asset has its own FTSO contract implementation in the IFTSO interface, which can be used to get the price information for the asset. To know which FTSO contract to use, we use a contract FTSO registry that contains mapping from asset name to the currently valid FTSO for the asset. This is important as FTSOs can be upgraded and the registry should be considered the source of truth for currently valid FTSO for each asset. So how do we get the address of this FTSO registry contract? So we use a special hard-coded address 0x10003, which you can see on the screen, where a special contract price submitter is deployed on both the Flare and the Songbird network. The price submitter contract is used to submit the price information to the FTSO system and is the only contract that can submit the price information. Since the contract has a fixed address, the Flare team has added some additional methods to it so that it can serve as a gateway for important contracts. One important thing is that the price submitter can be redeployed to a new address. So whenever that will happen, we are going to announce it, we will update the docs, even I will create an updated video, so you don't need to worry about it. So now, how exactly does an app get the price on Flare or Songbird? So the easiest way is to use the get price family methods of the FTSO registry. So there are two different methods. One accepts asset symbol as a string and the other accepts asset index. We will use the string one as it is easier when using the FTSO system for the first time. If you are still confused, no need to worry. Let's jump onto the Remix and write code to use the FTSO to retrieve price feeds. So I'm on Remix and I've created this basic template for us to retrieve our price feed data. So here I have imported the implementation of our FTSO contract interface, and also I have imported the implementation of price submitter interface and the FTSO registry interface. So you can actually visit the periphery package that we are using, right? And you can visit it. The link is in the description of this video, so you can check out the readme file as well. There are some example use cases, and so if you want to use the interfaces deployed on Flare networks, just import them in your contract code. So you can just copy these lines and you can paste it on your code. You can check out the code as well, and there are a few examples as well. The links to this periphery package is in the description, so you can check out that. So now let's jump on to our actual contract. So I have defined this contract name simple FTSO example, and under which I have defined two functions. One is the get price submitter function, which will help us to get the price submitter address, and the other is get token price, which will help us to get the token price of that token symbol. So we'll have to pass on the token symbol and we will get the token price for that. So let's define our get price submitter function. So what this will return, it will just simply return our price submitter address. So just use the interface of the price submitter and pass on the address that we have. So as already discussed, that our price submitter contract is deployed on a fixed address. So you can actually visit the Flare documentation and you can get the contract address where the price submitter is deployed. You can get this address. The link to the documentation and the particular doc is in the description. So here it clearly says that the price submitter contract is deployed at an immutable address, right? This address. And for your information, this address can change, and whenever it changes, there will be announcement, right? So just copy this contract address and paste it here. So our function for retrieving the price submitter, for getting our price submitter contract is completed. So one thing here to observe is that we could have actually created this price submitter function as a constant, but you don't need to worry. A smart compiler should be able to optimize this function call and make it a constant. Okay, and we can actually use the constant one. We can make it constant in our next example, right? So you don't need to worry about that. Now let's move on to our next function, that is the function get token price, which will actually take one input, that will be the token symbol, right? So if you want to get price of any of the token or any of the cryptocurrency, what you have to do is you will have to provide the token symbol for that particular cryptocurrency. So for example, if you want to retrieve the price of BTC, you will have to pass on BTC. If you want to retrieve the price of XRP, you will have to pass on XRP. And if you are right now, we are on constant 2 testnet. We will do this on constant 2 testnet. So for testnet, you just have to add test in front of the token symbol, that is text XRP, right? We will do it in a bit a second after we define our function, we complete our function. So this will return our price. So this function will return the price and will also return the timestamp, right? So now let's actually define our function, right? What this function will do is basically, first of all, let's get our FTSO registry contract, right? Which is a very important contract, because FTSO registry contract will actually call the get current price method, right? So it's very important to retrieve the FTSO registry contract. So let's just use the interface that we imported from our periphery package. So here you go, right? And now let's define the FTSO registry so it can store the contract address. Okay, now let's again call our FTSO registry interface, and it will be an address. So now we will use our get price submitter function to get our FTSO contract, right? So when you visit the documentation, you can see that you can use the price submitter contract to actually retrieve all these smart contract address like get FTSO manager, get FTSOs, reward manager, claim setup, and this get FTSO registry, right? You can do that. So go over and explore that other stuff as well. But for here, we will be just calling our get FTSO registry, because right now we just want our FTSO registry contract, right? So let's just use and call that method. Yep, awesome. So and now we will use this FTSO registry to actually call the get current price method, which will actually give us the price of our token. So this will return the price and it will return the timestamp as well. You can visit the documentation. It clearly explains what it will return, what it will not return, what every function will return. So you can visit the documentation and you can check it out. So FTSO registry, and we will call our method named as get current price, right? Get current price, and we will also pass in the token symbol. The price for P should be capital. Let's pass on our token symbol, which we are taking as input. Yeah, so that's simple, right? So this line actually just gets us the get current price of the token symbols that we are passing. So almost our contract is completed. There is a small error. Okay, so our get FTSO registry is actually a function, so you will have to call that as a function, right? So our contract is completed. There are no errors. So now let's actually just compile our contract, right? And it is already compiled. That is good. Now let's actually deploy this contract on Constant 2. So make sure you have some Constant 2 faucet in your MetaMask, right? So from here, just use injected provider named as MetaMask, and you will be able to connect it. So just allow and then connect it. Then your MetaMask will be connected to your MetaMask wallet. Your remix will be connected to your MetaMask wallet. So here I have 100 testnet token. If you do not have any, please just go to the faucet and get some Flare faucet, and make sure that your network is Constant 2, right? And once you've cleared that, now let's actually deploy our simple FTSO example contract. So once you click on deploy, it will automatically get deployed. So I've deployed our smart contract, and now let's actually interact with our smart contract and call the get token price function so that we can get the price of the token that we want, right? So there are two actual functions that are available. One was the get price submitter that we defined, and the other was get token price. So if we click on get price submitter, it will just give you the address that is this address, this where the price submitter is actually deployed. It will return just the price submitter address. And the second thing is the get token price. So for that, we have to provide an input that will be the token symbol of the cryptocurrency that we want the price of, right? So right now, as I said, that I am on the Coston2 test network. So you will have to actually write test, and then you will have to write XRP. So if you want the price of XRP, for example, let's type XRP and just click on get token price. It has returned the token symbol. As you can see in the input as well, we have passed on the text XRP token symbol, and here the decoded output is, first it gives out the price, that is 38140, so that will be around $0.3814, and we also have our timestamp. So we have successfully retrieved price feed from the FTSO. And there is one more thing that you can do. You can also call the method that is with decimal. So you can actually get the decimal value as well along with the price. So here I will add get token price with decimal. So along with our value, along with our price, it will also give us some decimal values as well, right? So I have added our function that is get price with decimal, and the input will be same. We will just pass on the token symbol, but the output will be different. There will be one more extra thing that will be added, and that will be our unsigned integer 256. That will be decimals, right? So we will get one decimals output as well. Here you don't need to change the FTSO registry part, it will be the same, but here you can just add your decimal that you have just added on your output. So you just add the decimal, and here you will again call the get price function with decimal. So just write here with decimals, make sure that the W and M and W and D are capital, right? That's very important. So let's finally deploy our edited smart contract, that is the simple FTSO example, and we will deploy it again. Make sure you are on Coston2 test network and you have enough Coston2 faucet. Just confirm your transaction and your contract will be deployed. So again, go to the deployed contracts, that is our simple FTSO example. So like this time, let's actually check the price of Bitcoin. So for Bitcoin, the token symbol is BTC, but we are on testnet, so we will pass test BTC, just pass in that, and then click on get token price. So this time here you will see that we got three outputs. That was the price, again the timestamp, and we also have a new output that is with the decimals, that is 5. So here you can also check it from here as well, that right now you passed on the text BTC input, and on the output side you have the price, the timestamp, and the decimal. So this is how you can actually retrieve the price feed, the price information of these tokens. So right now when I'm creating this video, around 7 to 8 tokens are supported, but we are planning to add more as well. You can actually check the list from the documentation. You can visit the Flare documentation of FTS, so you will get all the information there. So now I have one more example that I have already created. So as I said, that there are number of things that you can do, and there are number of methods that you can call from FTSO registry, and one such method is get supported symbol. So I have already written the smart contract. You can create this function as a constant. So for this example, I've created this function. I've not created this as a function. I've created price submitter as a constant. And now I've created one more function, that is get all symbols. So this will actually give us all the symbols that are supported by FTSO, and what it will return, it will return an array of our supported symbols. What are the symbols that are supported? That will return it in the form of array. So again, you are getting the FTSO registry, and after that you are from FTSO registry, you are calling the get supported symbols method. Actually compile and deploy our simple FTSO example 2. Just click on compile. It has compiled successfully. There are no errors. Now let's actually deploy our smart contract. Again, make sure that you have enough Coston2 FLR. That's very important. Now let's sign the transaction. So we have successfully deployed our smart contract. Now let's go to our contract. Again, there are two things that you can call. One is the price submitter. So what this will give is, this will give you the address of price submitter. Again, this price submitter address can change as well in the future. Now click on our function get, is the get all symbols. So once you click the get all symbols, you will be able to see all the symbols that are supported. So here you can see C2FLR because we are on testnet, right? So this is very important. Since we are on testnet, it's rather than showing FLR, it shows C2FLR. And in front of every other token symbol it shows test because we are on test network. So this is test XRP, LTC, Litecoin, XLM, Dodge, test, Algo, BTC, Ether. All these tokens are actually supported. And if you do this same thing on the Flare mainnet, it will show FLR. Like if you are on Flare mainnet, it will show FLR, XRP, XLM, Dodge, without the prefix test. So I just want to clear it so that there are no confusions out there, right? And yeah, successfully we have retrieved our price feed. We have called the get ft and we have called the get supported symbol method as well, and there are other several methods as well that you can use and you can explore. So just go on to the technical documentation of Flare and check out the FTSO part, what are the methods available. Just start exploring FTSO and see what you can build using FTSO. If you have any doubts, do join the Discord server of Flare. There is a particular dedicated channel there. If you have any doubt, you can ask there as well. And if you are building something with FTSO, do share it on Twitter and tag me and the Flare. We would love to see you and maybe I can give you some swags, right? That's all for this video and thanks a lot for watching. So stay tuned and we will share more tutorials on state connector, FTSO and how you can actually build on Flare. Thank you for watching. Just go and start building on Flare. What are you waiting for?